So we had a beautiful Saturday, a not so beautiful Sunday. Cloud cover, rainy. Had quite a bit of snow in the afternoon. It didn't stick on the ground, of course, but I'm looking outside and there's all these flurries coming down. I'm like, oh my goodness, yeah, it's snowing after being like 70 plus degrees on Saturday. So really kind of odd, but hey, this is it. This week and then spring break, which actually arrives like Friday because there's no school Friday officially. So, yeah, 4 day week, spring break, take us to the end of the month, basically. Because let's see, what is that date that we come back? We come back on the 30th. So, time we get back from spring break, March is pretty much over. So, we'll be kicking right into April. So, things are just boogieing right along here, as it often does in the spring semester. Once you get some momentum, we just blow right through it. So, all right, let's take a look. I haven't looked to see what we're doing this week. Software development, right here. Look at the grade screen. We're down to encryption. We've looked at computer vulnerabilities. We've looked at cryptography. Now we're looking at encryption this week. And then when we get back to spring break, we'll look at security careers and beyond. But let's see what's going to wrap us up into spring break here. 5.03 encryption. Security, not one size fits all. So security technology may be ever evolving, but that hasn't stopped hackers. Hey, to them, newer and better security means new hacking challenges. But when security is a moving target, how do professionals decide which security measures to implement? Well, first you start with the basics, right? Then you analyze a situation to determine the best measures to use. So security 101. Impenetrable security is built on a solid foundation. No matter the system, experts follow these basic security protocols. Number one, stay updated. Whether it's a computer, a mobile device, or gaming system, always make sure your system and software are up to date with the latest versions. Because a lot of those updates that come all the time are because of security flaws that they discover, and they send a patch and they send something to fix those security flaws. So updating things regularly is a key part. Protect your passwords. Use strong and unique passwords. Don't write them down. Don't put them on a sticky note. Put them on your screen. Leave them where someone might find them. Use multi-factor authentication, which a lot of websites force you to do now. Some of them still have it's optional. Would you like to have us text you or something? Yeah, we probably should turn those on. 2 steps are better than one. A strong password is important, but multi-factor authentication is even better. And yet it gets to be a pain every day having to do all that, but it's better than getting hacked. Pay attention. Use caution when browsing the internet. If your browser alerts you to a security concern on a website, there's usually a really good reason. So take heed of that. Install antivirus software. And antivirus software that includes a firewall is your best line of defense against attacks. So I have antivirus software that covers my computer at home, and I can install it on my phone and tablets, and so it can protect a lot of stuff there. Which security measure is right? Well, before implementing a security measure, experts analyze the situation to be sure they're choosing a method that makes sense. Think you have what it takes? Let's go ahead and take your decision making skills for a test run. Club security. As the chair of technology for your school's environmental club, it's up to you to make sure the club's information is stored digitally and securely. Read through the following scenarios and select which cryptography method you would recommend in each situation. All right, so we got a little quiz on page one. Okay, yeah, let me go ahead and make that a little bigger to see it on the screen. The club's president wants you to send a list of active students, including their name, address, phone numbers, and student IDs. The president doesn't want this personal information to be readable, just in case someone else happens to obtain the file. Which method is best for the scenario? Would we use encryption, digital signature, or authentication? What do you think? To send a file that would not be readable? Absolutely, we would encrypt the file. Let's see. Nicely done. If the file of personal information does happen to be obtained by someone else, the data will be encrypted and unreadable. The club's vice president is finished planning the year's event and volunteer opportunities. He's posted the calendar on the Environmental Club's website, but wants to make sure only club members have access to the calendar of events. Which method is best for the scenario? A digital signature, encryption, or authentication? Yes, let's authenticate to see if they're allowed to access the page. Great choice. Authentication allows you to verify a user's identity. After club members verify their identity, they will have access to the calendar. Okay, the club's secretary needs your help collecting waivers from members for the upcoming volunteer trip. The Environmental Club wants to go paperless to reduce waste, so she emailed digital waivers to the entire club. She wants to make sure that the person receiving the waiver is the same person sending it back. Which method is best for this scenario? Encryption, digital signature, authentication. Absolutely, since the digital signature would be a way to make sure that it verifies that it's the right person. You got it. Ensures the member who receives the waiver is the one who's signing it and sending it back. So it should just be a scorecard. It is 3 out of 3. Fabulous job. All right, we're ready for page 2. Securing user input. If you've never forgotten a password or username, are you even human? My goodness. You might have a great memory, but chances are your users do not, especially when they need to create strong passwords and unique usernames for all the different applications they use. So as a programmer, it's your duty to protect their information, even if they can't remember it. So password recovery best practice. We all have to use that password recovery sometimes. Some website you haven't been on forever, and it's like, oh, I have no idea what my password was because the one I thought it was didn't work. When users request a new password, programmers must authenticate their identity before sending them a new one, right? You shouldn't be able to click on a page and it just says, oh, use this password. Follow these best practices to ensure your program's password recovery is safe and secure. Use generic error messages. If a user incorrectly enters their login information, let them know, but don't tell them specifically if the username or password is incorrect. This prevents unintentionally giving clues to someone trying to break in the account. Yeah, I see it all the time, which actually frustrates me because it's like, well, what was wrong? Did I put in the wrong username or wrong password? It doesn't tell you because if it just says the password's incorrect, if someone's trying to hack in, oh, that is a valid username. At least, if it tells them just the password's incorrect. So that tells them, oh, all right, so I just need to find the password. So examples, say login failed, try again, or invalid username or password, try again, right? And we see that from time to time. Recovery authentication. A recovery authentication process is used to prove someone's identity before sending a new username or password. So when users first register, ask them to answer some security questions about some personal information. If a new login information is requested, they'll need to answer these correctly to receive it. So we see that sometimes. What's your mother's maiden name? What was the make and model of your first car? It'll say, what was your high school mascot? What was your first pet's name? I've seen all kinds of different security questions like that. Note, even though both processes ask users to prove their identity, recovery authentication is not considered multi-factor authentication. Okay, so this is not considered multi-factor authentication when you have to do recovery authentication. Because it's not going to do this every time, for one thing. It's only like when you request a new password. Keeping user passwords secure, programmers must go above and beyond when it comes to keeping user passwords safe and secure. So when developing programs and applications, be sure to follow these best practices. Never store user passwords in plain text files or databases. Always encrypt the database containing passwords before you send it to them. So you want to keep that file where it's not easy to read at all. So you get into that. I know sometimes I have some of these sites where it's like, if you want to recover your password, we'll email you. If you can't remember, we'll email you a link. and it'll say enter your email address. And then I have some of them where I'll enter my email address so it can send me a link. It'll say if there is a user account associated with that email address, then you will have just been sent an email. So it won't even tell me for sure if the email I sent is the email from my account. So it's like, I'm not even going to tell you for sure that's the right email, but if it is, you'll get an email there. All right, protecting data with encryption. One of the most famous encryption techniques in history is the Caesar cipher, named for Julius Caesar. This cipher was used to protect his messages to the military. Its method's simple, relies on two alphabets, one normal and one cipher alphabet that's shifted by a certain number of positions. Probably tried to do one of those as a kid or something. In the example pictured, the cipher is shifted 3 positions to the left so that A becomes D, B becomes E, C becomes F, and so on. And you can change that. Maybe we're going to shift it 5 letters or 10 letters, and maybe we're going to shift it right or shift it left. So you can create your own cipher simply by doing that. Now, someone that's pretty adept at it could probably crack it pretty easy because they can start looking at which letters are most commonly used and try to match those up with which letters are most commonly used in the English alphabet and that kind of thing. But the Caesar cipher is an example of a symmetric encryption. So this type of encryption doesn't take much time to execute, but can take a lot of time to decode without access to the key. Because of these qualities, programmers often choose to use symmetric encryption to send large amounts of data safely. In addition, Python can be used to create a cipher, so you can encrypt and send your own secret messages. So let's look at an example of encrypting messages with Python. Select each section of code to learn how to create a cipher and encrypt messages in Python, then play around with implementing your own messages. All right, so define main alphabet equals, and that looks very familiar. We could read that, but you know it all. Key equals 5. So the variable key stores the value that will determine how many positions the cipher will shift. New message. Right now we've created a new message that's blank. Message input. What message would you like to encrypt? Then we use this loop. For character in message, position equal alphabet find character. So the new position is the current position plus the key, which we've set at 5. Say this variable stores the new position of the letter based on the value of the key. That's a loop. New character equal alphabet new position. So it'll save it at the new position. Message plus or minus equals new character. New message, new character. And it prints it. So let's copy this. Just see how it works in person. Oh, it actually opened right up this time. All right, we've copied that in there. Oh, I copied some extra letters. That would create an error. All right, define main, down to main. What message would you like to encrypt? Good morning, class. There we go. Just do something simple like that. And here it is as encrypted, including the spaces. The spaces are encrypted as well, because you notice there's no spaces there. So you don't even know how many words the message is. ETTIER. See, those were O's. That was good. So the T's became the O's became T's all the way down. Good. So, good morning. So I wonder how a space became an E, or does it put it all together? GOODMORNINGCLAS. No, there's extra room in there. I'm not even sure how the spaces became the same as G, because the E is there twice. I put an exclamation at the end. That's also a space right there. So, okay. Well, there we go. So if we change it to like, I wonder if we can do -5. Let's try -5, just see what happens. Oh, that's fine. It just moved the other way. Now we got a lot of U's in there instead of E's. A lot of I's too. So yeah, we can shift it. left or right. -5, just shift it the other way. So yeah, you can play with it. There's you a encryption program right there for you. Right here in our text. Did you know when someone performs an action with brute force, it means that it takes an astounding amount of strength or effort, or both, to complete some task. Same is true in programming. Hackers sometimes resort to brute force attacks to crack ciphertext. This is a trial and error method used to obtain information such as a user password or a PIN number, personal identification number. To do this, they try every single key until they find the decryption key. That's what they call brute force. It's quickly, the program is written to try every possible combination. Not very sophisticated attack, but the effort involved is similar to finding a needle in a haystack, right? Because you're just going to try everything. However, many hackers can write programs in a system attempting all types of key combinations in order to break a cipher. It can be lengthy, depending on how long the key is that's trying to break, but the computer can quickly try over and over and over and over again. Page 4. Putting it all together. So you made it this far. That means two things. You've read about secret messages and you've implemented your own. Now it's time to put your Python skills to work and crack some code. So in this Python guided activity, you'll get a chance to decode a secret message. Think you got it what it takes? Go ahead and give it a try. All right, so hiding secret messages and cracking the code can be fun. Let's walk through the decoding process in this Python guided activity. Follow the instructions. All right, cracking the code with Python reverse strings. Read the code, try to predict the output, run the program, follow the user prompt, review the output and feedback. Experiment by changing the secret word to something else. Okay. Users enter a string. New string equals input. So there's where you enter whatever you want. Print. The reverse of the string is. So this code takes the string and goes backwards, given the value of ::(-1). Let's see what this looks like. Humpty Dumpty. Yeah, I just put something silly there. And there it just prints it backwards. So you can print anything if you use this bracket, ::(-1) bracket in reverse. You print anything in reverse using that little secret code right there. So it basically says, yes, print this, but print everything in reverse order. That's kind of cool. And changing the secret word to something else. Something else. I changed it to something else. Oh, no, I misspelled something else. Esle Genitimo. With an S there. Reversing strings. I read the code, predict the output, run the program, review the output, experiment by changing the secret word. That looks a lot like our last instructions. Reversing strings, main. New string equals, okay, just create an empty string. The old string is code word. So for character in old string, the new string is going to be the character plus new string. So it's going to be adding the characters in there and print that. So let's print. So there, it did it backwards for character in old string. So it started and added each one in reverse. Let's just put the word reverse as rever. So that's an interesting way to do that. So this saves that new string as the reverse of the original using this code right here. So as it goes through the loop each time, it pulls it and saves it backwards. Reversing strings again. New string, old string. Okay, so we have two empty messages. Read the code, predict that, but fill in the missing code to print the word Python in reverse. Okay, so first thing we need to do is put Python in here. And let's see, what was that loop? Let's see, it was new string. equals, was it character plus old string? Did I remember that correctly? Not exactly. Did you notice that old string variable doesn't have a value? Yeah, we did that. Somehow I got an N and then Python again. All right, what did I do different? Can you spot anything? I'm not sure. I was trying to do it. I wasn't paying enough attention knowing I was going to rewrite it, but let's go backwards. That looked like the same thing I did, except for there's an extra space for some reason. That's if I back it up a space, does that make a difference? Nope. Oh, I see the difference. Oh, wait. Character, I did character plus old string, and it's character plus new string. New string equals character plus old string. That's what I was doing. And then we got to put Python in old string. No, I still did it wrong. Oh, it is plus new string. Gosh, I did it again. There, I did it backwards. Character plus new string. Yeah, creating a new string. I got to keep adding the character to what the new string is as it adds a 1 by 1 backwards. All right. Interesting. Oh, we have an assignment template. I believe I have put this in our class. Let's go look over here. This is week 29. So in this one, it's not a programming assignment. Read all the directions for beginning. Selecting the best tool for the job. Understanding the best authentication and encryption methods for a job is important when it comes to protecting your programs and your users. For this assignment, you're going to review different scenarios. Choose the best security method to implement, like digital signature, encryption, multi-factor. Oh, what did I just do? Multi-factor authentication or recovery authentication, and then complete the chart. So there are 4 different scenarios. You choose the security method and tell why. Why is this the best security method? And then why does this scenario even require encryption? Why do we even need to do that? So there you go. That's what the assignment is this week. So you have this in Google Classroom. So you can just do that in Google Classroom, and then here you can just put done, or you can attach the file if you want, because it is a file you can share from there. You can attach the file or just hit done, and I can go get it from Google Classroom. But yeah, it's all about testing your knowledge about different security methods and figuring out why would you need to, why does it even matter if you protect this type of information with 4 scenarios. So a little different work here. Talk about security and all that fun stuff. Fortunately, this is a topic everyone's familiar with. If you log in anywhere, you've learned about security, just because our world is so full of dishonest people trying to steal everything they can get from you. It's just there's no moral and ethics out there in the world, so you got to fight for them. You got to fight to keep them, because a lot of bad folks. So, all right, guys. Well, if you got any questions, let me know. Otherwise, have a great week. We'll catch you next class.